Okay, let me share you the screen. Okay, and this is your first question. Okay?
Yes.
Okay. Give me 1 minute. Okay. So the first question is that calculate the shear capacity of 254, 146, and 37 UB as 275, and assume that we have assuming that. Okay. So first of all, you have to know the properties of 254, 146, and 37 UB. Okay. So for this, you have a database that is known as universal database. Okay. So let me show you a database. Okay. So this is the database. Yeah, this is books and data. This is books and data, Eurocode, stereo codes, and universal data. Okay. So this is is it seen to you, brother?
Where?
In
Where would it
screen,
be seen?
what are you looking? I mean,
No, I can't see your screen now.
okay. Means I had to back to the meeting, screen share, and desktop share. Okay, so is it
Okay, I can see it now. Yeah.
yes. Okay, so what is your section? So first of all, you have to see that what is your section. So your section was 254. Let me see again. 254, 146, 254, 146.
And can I ask a question? Does this chart apply to all the any question that has those numbers?
Yes. This is actually a British standard dimensions and properties table. So you
Okay. I
can.
see.
Okay.
Mm-hmm.
So first of all, you have to see your section properties. Okay. So what is your section properties? Let me show you. 254, 146, and 146 and 37. Okay. 146, 254, 154, 146, 146, and 37. Is this? I just highlight this.
I'll check that for you. Just
Okay,
now.
this okay. Is this properties?
It is 254, 146, 37. Yeah.
Okay. So what you need to do if you want to find the shear capacity of that section, you need a few things. Okay. So first of all, mm, just okay. Now you have seen is it looking for you? Okay. So first of all, you know that you have to know that the shear capacity formula, okay, shear capacity formula according to Eurocode is equal to AV, okay, Fy under root 3 omega. Okay, so now what you need to do is you have to find three things. The first one is AV, the second one is Fy, and the third one is this is a partial factor of safety. Okay, so the partial factor of safety is 1. Okay, so you don't need to find this one. So first what we need to do is,
what was the last one?
what, brother?
What was the last bit? What was it?
I don't understand your question.
The factor safety, the number one. What is that?
Yeah, that this is a partial factor of safety factor. So it is always equal to 1
in the shear capacity questions.
in shear capacity questions. Okay.
Okay, what was it called again?
This is a partial factor of safety. Partial factor of safety.
All right, and it's the omega one.
Omega. This is a
You
whole
just
factor of safety, brother. This is a whole omega. This one equal to 1.
okay. I see.
Okay. So
Okay.
now you have to find AV, Fy, and under root 3. So first of all, you have to see what is Fy. Okay. In question, it is written that your grade is 275. Okay. So what you need to do is you first of all you check the thickness of flange. Okay. Now see what is the thickness of flange. Here you see that thickness of flange is equal to 10.9. Okay. Thickness of flange is 10.9. So it is less than 16 mm. Okay. This is actually a limit. Okay, brother. If
Yeah.
your
Okay.
if your thickness of flange is less than 16 mm, so your grade will be automatically 275. Okay, per meter mm square. But if your thickness of flange increase to 16 mm, for example, it is 18 mm. Okay, and but less than 40 mm. Okay, you have to remember these values. Then your strength will be 265. Okay,
Okay, I see. If it's
it has
if it's
it is on table. Do you have the table?
if you could send it to me, that'd be
Oh,
better.
okay, I will send you. Okay, and see your WhatsApp. Steve code, Steve code. Uh, okay, maybe it takes a little bit time because the VPN is sometime takes a time because I'm currently in China, so WhatsApp is not working. Okay, so
Okay.
but for now, the value of Fy is equal to 275 mm, 275 Newton mm, Newton per mm square. Okay, now
Okay.
you have to find AV. Okay, the exact formula of AV is equal to A minus 2 of thickness of flange plus T thickness of flange plus 2R over thickness of flange. Okay, this is the exact formula of AV. Okay, but now in your question, he said that you can assume your AV is equal to thickness of flange multiplied by height. Okay, so you can assume, it is written in your question that you can assume AV is equal to thickness of flange multiplied by height. Okay, so we see that what is the thickness of flange and what is the height. Okay, so the thickness of flange is the thickness of flange here, thickness of web is 6.3. Okay, sorry 6.3. And height is actually the formula of height. 1 minute, brother, 1 minute. I am sending you a message from my Chinese number. Okay, and then I am
Okay.
sending you the Eurocode standard. Battery about to die. Yes. Have you received?
Yes, but
So brother,
the PDF, the chart, the
yeah,
British standard.
oh,
Where can I
oh,
find it?
Okay, I will send to you. Okay, I will send to you again. But now you just see the value of Fy. Okay, you see
Mm-hmm.
that there's a one portion that is about steel grade. Okay, the second one is about yield strength, and the third one is again yield strength. So it depends on the thickness of flange. Okay, so if your thickness of
Okay.
flange is less than 16 mm, so you see that in 27 275, again your value is equal to 275. But if your thickness
Mm-hmm.
of flange exceeds 16 mm, but again it is less than 40 mm, so it will 265 mm.
Mm-hmm. I
So
see.
but again there is a missing in this table. If your value is greater than 40 mm, then again this value is equal to 255. So you see that there is a difference of 10.
Ah, I see. Yeah, yeah.
Okay, so in this way you can memorize. Okay,
Okay.
so again come to our topic, and now what are we finding that AV, what is in what is actually AV is called shear area. Okay, brother. So the formula of the shear area is equal to thickness of flange multiplied by height. So you have a thickness of flange, but you don't have height. So height is actually total depth minus 2 times thickness of flange. Okay, so from table we see that what is the height is 256.
Mm-hmm.
256 minus 2 thickness of flange. What was thickness of flange? It was
6.3
10
was it?
10.9.
No.
It is a thickness of web 10.9.
All right. Okay.
So let us calculate the value. I have a calculator, you can also check. Minus 2, 10.9 multiplied by 6.3. Okay, so it is equal to 1475.46 mm square. Okay,
Okay.
now what you need to do is you just need to put the values. Okay, and why I multiply 10 cube power cube, because it is in Newton. Okay, sorry, it is in mm square, and it is equal to Newton per mm. So we need a units in kilonewton. Okay, so sorry, I'm sorry, it was 275.
Okay. Wait. So
So the
at the
answer is
bottom.
243.626 kilometer.
Okay. Let me just write it down. Just give me a sec.
Okay, brother, are you checking the solution or you answer?
Yes, yes. I'm just copying some of the notes down. Could you just go up a little bit?
Okay.
What was the so TW? What was that again?
And TW is thickness of web. Let me write
The
here.
thickness of what?
Web. Let me show you this thing. Okay, actually this is UV section is like that. Okay, brother. So it is like here, like that. Okay, so this is actually your breadth. Okay,
Mm.
this is your thickness of flange. Okay, so this is your total height, you can say D. Okay, and
Mm.
this is your thickness of web. Okay, so this thickness of flange is equal to this thickness of flange. Okay, so
Oh, I see.
basically what So basically what we are finding, that we are finding this area. Okay, this is shear area.
Which is AV.
AV. This is AV. Okay, so how can we find? I just D minus 2 thickness of flange. Okay. Okay,
I
one,
see. Okay.
and again, in if in your exam you have to find the exact value of AV. Okay, in this formula here you see that there is a R. So what is the R? R is this, the radius of this fillet. Okay, this radius of fillet. So these are the basic terminologies. Okay, so do you want to copy it? You can take a note.
Yes, just give me a moment. Yeah. Sorry, what was the value of TW again?
And TW is thickness of web is 6.3. Okay, you can see from here.
Okay.
6.3.
Hey, can you scroll down so I can And I just want to ask you here, the bottom part of the fraction, it's root 3 times 1 times 10 to the 3. Why did you times it to 10 to the 3?
Because here you see that our this value is Newton, mm square, and this is mm square. So we need an answer in kilonewton.
Okay.
Okay. That's
Oh, okay. Okay. Okay, we can move on.
okay. So now come to the next question. See that for now leave this question 2 and we start the question 3, because this type of question has same, you can say it is same type of. Okay, so you first better to understand this question. So in question number 3 he said that state the design strength Fy of F33210 UB. Okay, what he is actually asking, that he is just asking that what is the value of Fy. Okay, so
Mm-hmm.
I have told to you that Fy is depend on your grade as 355, but it is not only depend on 355, it also depend on your thickness of flange. So what you need
Mm-hmm.
to do is you just need to go on the table and see what is the thickness of flange of this section. Okay, let us see. 533, 533, 210, and 101. Okay, this one, it is three. There is 21, 210, 101. Okay, so you see that the thickness of flange is 17.4.
Yeah.
Okay, so your
So
thickness of flange exceed to uh,
exceed
16 mm.
16.
So what is your value? Then your value is 345,
345.
not 35. Okay, this is wrong.
Mm-hmm.
So your value is 345. Okay, you can see also from the table that I have sent to you. Okay,
Okay. So
similarly,
it's just asking for the. Okay, I see. Yeah.
so should we proceed?
Yes. Yes. Yes.
Okay, now go to the question number 3. State the design strength. Again, we have to see the design strength. 305, 106, 305, 305, 165, and 54. Okay, this is. So in this case, you see that the thickness of flange is 13.7. It means that it is less than 16 mm. So what you need to do is just it is equal to 275.
So this one was correct.
Okay, this one is correct.
Okay.
Okay, now you need to do is question number 5. Calculate the major axis YY moment capacity of 254, 146, 37 UB to 75. Assume that lateral torsion buckling, assuming a full lateral restraint. Do not type the units. Okay, okay. So this is a little bit, you can say, it takes little bit time like this question. Okay, so what you need to do is you need to find the you need to find the capacity of section. Okay, so first of all write the section, the name: 254, 146, 254, 146, 37, and this is called UB. And what he's saying that he's saying that against a major axis. Okay, must remember that it is saying about the major axis. So it is asking about major axis. So what is the formula? The formula for bending resistance is equal to WPL Fy, our partial of factor safety. So again the partial of factor of safety is equal to 1. Okay, now the question is what is WPLY? Okay, so WPLY is a plastic section modulus against stronger axis, because in question he is asking for stronger axis, so it is asking about plastic section modulus. Okay, so
Mm-hmm.
and Fy, again Fy is depend on your grade and thickness of flange. So what is, so first of all we see that what is Fy. So in question the grade is 275 275 Newton mm. But we see that what is the thickness of flange for this section. Okay, so 254, 146, 254, 146, 37. It is already selected. So the thickness of flange is 10.9. It is less than 16 mm. So automatically the value of Fy,
275.
so Fy is equal to 275. Okay,
Mhm.
now we see that what is the plastic section modulus of this section. So the plastic section modulus of this type of section is written here. Okay, go to the page down, and this is 254, 146, 37, 254, 146, 37, 254, 146, 37, 246, 1. Okay, so you see that this is your plastic section modulus. Okay, so don't be confused on one thing, that in question he is asking that about stronger axis, but he called the stronger axis as a y, but these tables considered x-axis as a stronger axis. Okay, so you should not
Mhm.
take this value. Okay, you have to take this value. Okay, so
Okay.
your plastic section modulus is equal to 483. And again, uh remember to follow the units, because in these whole things, what is matter, the matter is, it is the all of the values are considered in centimeter. Okay, so it is 483. Okay,
Mhm.
483 centimeter cube. 483 centimeter cube. Okay, so just you need to put these values on table. Answer, what was the formula? F W P L Y F Y hour. Okay, so 483 multiplied by 10 cube multiplied 275 and divided by 10 power 6. Okay, so first of all,
So
why?
do you excuse me, just one sec. Do you times it by 10 times 10 to the power of 3? Is
Yes,
that because it's in centimeters cubed and
I convert into mm. Okay, and again it was already on mm, so I need answer in kilonewton per meter. Okay, so I divide by,
Mhm.
first I divided by 10 power 3, and then again I multiply 10 power 3, so this equal to 10 power 6.
Mm.
Do you understand
Mhm.
this? So what is the answer? Answer is 132.825 kilonewton.
Right, can you just go back to the initial formula itself? I want to see it again. Okay, I can't really read that. What's the formula?
This is actually the bending resistance of section. This is your bending resistance. Bending
So
resistance,
the bending resistance section.
okay, of section. This is your plastic section modulus. This is your yield strength.
Sorry, the thing at the bottom of the fraction. What is that?
This is again partial factor of safety.
Okay, but
Partial
what
factor of
symbol is it
safety
supposed to be? I can't really tell.
is equal to 1. It is
No, no,
called
I mean like the symbol itself. What is it?
this is actually, and the symbol is like that.
Okay,
This is omega m and naught.
okay. Mm. All right, can you just scroll down? I just want to copy more notes down, please. What's the unit of the final answer?
Kilonewton meter.
Kilonewton meters, yeah?
Yes.
Is it kilonewton meters or kilonewton per meter?
No. It's not a per. It is
Okay.
kilonewton meter.
Okay, I see. Sorry, is the final answer 132.825 or is it 132,000?
No, 1000. It's not 1000. It is 132.82.
Okay, I see. Okay, can you just go back to the question sheet? I just want to see it.
This one?
Yeah, calculate. Capacity. Can you just briefly go over the question again? I don't quite get how you used this formula after reading that question. Like, how do you know that that's the formula you have to use?
Because I know the formula is
Yeah.
written in your code. And this is what I'm saying, that this is actually find the shear capacity. Okay. So the shear capacity formula, I have wrote that AVFY under root P.
Yeah.
And
Well, for question 5,
yes,
like
the just the
it
formula
doesn't
for
say anything
bending.
about bending resistance.
Yeah.
So how did you know that that's the formula you have to use?
Actually, how can I get that? Because it is said that the calculate the major axis moment capacity. So moment capacity is just like a bending capacity. So moment capacity mean bending capacity.
Oh, okay.
Okay, is
Okay.
actually a beam. This is a beam. So do you know that beam is always bend. So it is called bending capacity. Do you understand this?
Okay, I see.
Okay. So We go to next question like that. Uh, he said that a roof beam is subjected to a permanent and variable actions of GK is here, QK is here like a snow load, and wind load is this one. Okay, so calculate the maximum gravity downward combination of SRT section. uh, I think it is like a SLS action. Okay, I think he wrote by mistakenly as it was SLX action. Okay, let me give you some, will help you from notes. Okay, actually we have three loads. The first one is permanent load, the second one is variable load, the third one is snow load. Okay, so let me show you a simple slides of, and this is the notes that I have that I usually used. Okay, so let me, okay, and this is what I'm saying, 1.3, sorry, but it is not a 1.3. Let me show you. Impose of 0.7, 0.5. This is like, now what you need to do is you have to actually rememberize these two factors. Okay, 0.5 and 0.7. Okay, so what you
Mm.
need to do is you just add these values like 0.7. Okay, plus
Mm-hmm.
this is a variable load, so you have to multiply with 0.7, 0.7 times 0.6, and at the last 0.5 time of 0.5. Okay, like just you have to add the values like 0.7 plus 0.7 times of 0.6 and 0.5 times of 0.5, so it is equal to 1.37.
Right, could you write it down? Because
Just
that was a lot of numbers to take in.
one, it is, this is the formula, gk plus qk, it has a factor of 0.7 and 0.5 of wind load. Okay, so what is the value of 0.7 plus 0.6 plus 0.5 of wind is equal to 0.5. Okay, so the answer is 1.37.
Okay. Okay, I see, I see.
So this question we do for the next because it is little bit detailed. So we again go to the this type of question UB type section. Okay. So in question is, he said that state the classification number, okay, for the pure
Mm-hmm.
bending action. For the pure bending action, so you have to so again you need to first write down the section, okay, like 305, 165, and 54. So right here 305 multiply by 165 multiply by 54, UB section, and the grade is 275. Okay, you first need to see the section properties. Okay, so what section properties do you need it? Why classify the section? The first section property you need is breadth, okay, total height, thickness of flange, thickness of web, and R. Okay, these five values you need to find, you need to actually find the section classification. Okay, so we go to the
Mm-hmm.
table 305, okay, 305, 165, and 54. Is this the section? Okay, so just noted down that values. What is the 166.9? 166.9. Okay, height is 310.4, 310.4, and thickness of flange is 13.7, thickness of web is 7.9, and R is equal to 8.9. Okay, mm. These are all the values in mm. Okay,
Mm-hmm.
so what you need to do is you first need to find what is the grade, what is the fy. So tell me what will be the fy.
The FY is 275.
270.
275.
Yes. Okay, so now you have to first find E. Okay, you can say that this is E. The formula of E is equal to 235 divided by Fy under root. Okay, so this is the formula. You just need to rememberize the formula. So is equal to 0.92. Now these are just the steps, brother. Okay, now you have to check your flange, that in which section your flange lies, and then you check that in which section your web lies. Okay, so the formula of the flange is equal to, can say lambda is equal to breadth minus thickness of web minus 2r divided by 2 thickness of flange. Okay, so this is the formula. What you need to do is you just need to put the values. Okay,
Mm.
so what is the values? B equal to B equal to 166.9 minus thickness of web is equal to 7.9 minus 2 R is equal to 8.9. Tell me if I if the values are wrong. Okay, 13.7. Okay, so the answer is 166.9 minus 7.9 minus 2, 8.9 divided by 2, 13.7. Okay, so this is equal to 5.13. Okay, 5.15. Okay, so now the limit is actually, now the limit is 9e. So what is 9 and e is equal to 0.94? So let us see. So it is equal to 8.28. It means that, sorry, it means that our actual value is 5.1, and the limiting value, this is limiting value is 8.28. It means that our limiting value is greater than our answer, so it is class 1. So it is class 1. If this value exceed to this value, so your class section is class 2. Okay, brother, do you understand this?
I see.
Okay,
I see. So
now, yes,
right. So that's the answer. The answer is class 1.
class 1, but we have to check the web also. Okay, so the
Mm-hmm.
web is, the formula for the web is, first of all you have to height minus 2 thickness of flange minus 2r divided by thickness of web. Brother, can you please, can you just think for a minute and tell me the derivation of this formula?
The what? Sorry.
I say that, can you imagine, yeah, or can you think that what is the derivation of this formula? Where from this formula come? What is the origination of this formula? Like, is this formula or this formula? Is it difficult to remember or it is easy to remember?
I'm sorry. I don't understand what your question is.
I'm saying that this is the formula you have to remember during the paper.
Mm-hmm.
Okay, but what if you forget this formula?
Mm-hmm.
So can you think for a minute that what is the derivation of this formula? Like, from how can we get this formula? So you just need to remember this formula and come here. So it is not different. Depth
Mm.
minus 2 thickness of flange, and we just again subtract 2r. So this is your depth and this is your thickness of flange, thickness of web. Okay,
Mm.
so what is the formula? Depth. So what is the formula? Depth minus 2 thickness of flanges minus 2 times r and divided by thickness of web. Similarly, the formula for this one is also the same. Okay, thickness
Mm-hmm.
minus thickness divided by 2, then we just take the half and then take we minus. So in this way you can remember as a formula. But now we just need to put the values here. Okay, let me change the color. So what is the value of lambda? What is the height? Height is actually height is 310.4 minus minus 2 times thickness of flanges. So thickness of flange, I think thickness of flange is 13.7 minus 2r. the value of R is equal to 8.9 divided by thickness of web. So thickness of web is equal to 7.9. So we just took, I am calculating the values. So this is 33.56. Okay. So now your limiting value for UB section, just remember that your limiting value for UB section is equal to 72E. Okay, so your 72 and
Mhm.
0.92. So this is equal to 66.24. Okay, so again your limiting value is greater and your actual value is less than. So this is
Mm.
again class 1. So overall your section lies in class 1. Okay, so do you understand this?
Okay, I see. So what was the answer, the one I actually answered on the sheet? What was it?
1.
You can go back to it. Oh, I
This.
didn't show the answer.
Okay, like it's like 1, 2, 3, 4, 5, 6. Okay.
Okay. So it's
uh
class 1.
yes, a class 1. So but
Okay.
how can you say that if your section is greater than, for example, if your value greater than here, if your value greater than 10, if your value is greater than this value, so your class is section 2. Okay.
Mm-hmm.
1 minute, I just send you complete code because maybe you memorize the formulas better. Let me send you complete Eurocode. Yes, I'm sending you. Mm, open this file.
Uh, it's okay. Yeah.
Go down
Mm-hmm.
and come to the page 12.
Page 12.
Okay. Have you come?
I can't find page 12. Where are
Okay.
the
Let me see you. Are you looking? 1 minute.
Yeah.
Screen is. Are you seeing this screen?
Yeah.
Okay. Now, see, this is the formula sheet. Okay. So this is a very comprehensive formula sheets. Okay. So, let me. Okay. So brother, this is your, again, this is your table where you see that what is the thickness of flange, and this all is your Fy. Okay. Now
Mm-hmm.
see that if your value for flange is under 9e, your section is class 1. Okay. But
Mm-hmm.
if your value is exceeding 9e but less than 10e, your class section is class 2.
Mm.
Okay. But if your value greater than 10e but less than 14e, then your section is class 3.
3.
And if
Mm.
your value is greater than 4e, then your class section is 4. So okay, in Eurocode only there are 4 section classifications.
Mm.
Now this is actually, brother, for the flange. Okay, and this is for the web. Okay, so
Mm-hmm.
now see that if your value is under 72, it is class 1. If the value is 83, class 2. And if the value is 124, the class is 3. Now the
Mm-hmm.
question is that where we've used these let me draw. Okay, but the question is that where we use this table. Okay, so brother, you see that in question he writes that this is very important thing, and he said that, where is your question paper? Yeah, this is your question. So he said that for bending action, you see that.
Mm-hmm.
So if this formula is actually for bending action, sorry, this formula that I have solved. But if you have a question and he said that your the- your section is under compression, then for flange you are using this formula, and for compression you have used these formulas. Okay,
Okay.
do you understand this?
I see. Yeah. Yeah.
And let me show you some more formulas. Okay, maybe you need these formulas in next questions. In again, this formula you need in next questions. And this is the formula which
Mm-hmm.
I have. This is your plastic section modulus. Okay.
Okay.
Now the question is, come for 1 minute. Uh, for this question, your LTB is 12. Okay, now it is little bit a short question, so we solve this because it is little bit very long question. Okay, this is long question, this is long question, and this question again needs some, these are also little bit you can say lengthy, so we, it is much better to solve this question. Okay.
Okay.
Okay, brother, and it is written that a floor is subjected to a permanent and variable load of this one. Calculate the maximum gravity universally distributed load of SRT action on beam CD DC. One thing I am little bit, you can say, confused, because I have never ever maybe listen this word SRT, because there are two limit state, SLS and ULS. Okay, let me again check from internet, because S R S R S T R STR, combination of action. Yes, again is it is saying that yeah, what is the value for What is the difference between unit or STR? So it is either your LSS, your ULS, or SLS. Okay. So you can ask to a professor. Maybe he is asking for you. It is in this question he is asking for ULS. Okay. So you can ask to a professor, and the remaining
Okay.
question when we will do. So we will more clarify it. But now I am pretty sure it is asking for ULS. Okay. Now what you need to do is you have to increase this load. Okay. How can you increase? You are increasing your load by 1.35 of this load 6 and 1.5 of this. Okay. So no, sorry, 2.5. So what is the value? 1.35 of 6 plus 1.5 of 2.5. So it is equal to 11.85 kilonewton per meter square. Okay. Now what he is saying that he's saying that calculate the maximum gravity uniformly distributed combination action on beam CD. C,
Mm-hmm.
D, 3C and DC. Let's see where is C3. This is C and this is 3. Okay. So first the point is here. Let me change the color. Is this the beam 3C or and D3? So this is the beam. Okay. He
Mm-hmm.
said that find the load on this beam. Okay. So this sign is means one way distribution. One way distribution. So what you need to do is you see that you have to follow, you need to calculate the load on this beam. So you have to take the tributary area. So what is the tributary width? Half and half. Okay, what is the half of 4? 2. And what is the half of 5? 2.5. So the total breadth is 2 plus 2.5 equal to 4.5. So what you need to do is, this is meter, this is kilonewton per meter. So what you need to do is just multiply these values. 11.85 kilonewton per meter multiply by 4.5 meter. Okay. So this will be, your answer will be 53.325 kilonewton per meter. This is
Mm-hmm.
your answer. Okay.
Okay, I just want to
So
ask,
yes, yes, go ahead, Khalid.
just go up a little bit to the question. Where did you get the 1.35 times 6
Yeah,
and
this is
1.5?
actually the combination what which I have asked you to, that actually what I am little bit confused, that either they are SLS or ULS, but I am pretty sure this is ULS. Okay. In ULS condition you have to actually increase your load. Okay. Like this table, this is 1 minute, this is your table. Let me search here SDR. Maybe we find that ST, no, STC. What are SRT? Sorry, SRT.
It's STR, you mean?
SDR. Sorry, SDR. See, there is no SDR load
Mm-hmm.
combination. Okay,
Mm-hmm.
so because this is a very famous notes, and this is a very good notes that I am using about uh, design of Eurocode. Okay, so here you see that there is no STR. there is always two condition. Let me show you. ULS, this is ULS and SLS.
Mm.
Okay. So these actually, uh, but I'm saying that if your professor said that this is your SLS condition, then you need to add these two values. Okay, 6 or 2.5. Okay, 6 or 2.5. But if he said that it is ULS, then you have to multiply 1.35 with permanent load. Okay, what you need to do is, I just here write here summary. Okay, if he say that it is SLS, then you just need to add permanent plus variable. Okay, but if he say that this is ULS condition, then you have to multiply 1.35 with permanent and 1.5 variable. Okay,
I
so
see. Okay.
this is actually the table factors that is I taken from Eurocode 3. Okay, do you get it?
Yeah, yeah.
Okay, I think, brother, we should end the this lecture because I think the time is already finished, and
Okay, but
we yes.
um, you said you'd do all the questions, but can you just give me the answers to the ones you haven't done? I just want the answers.
You want to answers. Okay, okay. It means that you just need answers one by one.
Yeah, yeah, please.
Okay, okay. I will send you it to you. Okay, I will send it to you. The question
Okay,
that
if
we
you can
have
send me
solved.
just the answers for all of them.
Okay, okay. I'm starting to write on your WhatsApp. Okay,
Okay, with
okay.
with uh
Yes,
with the the,
with
the with the number of the question as well, just the answers.
okay, okay. I am okay.
And if you can just go back to the question sheet itself, I want to show you something.
Mm, this one, this.
Yeah, okay. If you scroll down, question 7, see the one with no number, that above number 8, that's question 7, just to let you know.
Oh, so there is no question 6,
No, no, question 6 was the very bottom one, the one with the diagram.
but it doesn't look.
No, no,
But
it's
it
at the very bottom, question 6.
variable.
It's the one we just did, the STR and the ULS.
But what about question 7? This is
No, I'm
question
just
7.
telling you that one, the one with the 2.7 kilonewtons.
Okay, okay. Yeah, 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 yeah. This is question 6. Okay, okay, okay. Yeah, yeah.
Yeah. So I just want the answers to the questions.
Okay,
I really need
I'm
them, brother.
just write it to you your answers here. Okay.
Okay, brother. Also, just before we end the call, I want you to look at some more work that we could do together for a later
Okay,
time.
okay. What type of work?
It's um it's just a few questions. I'll send you over the questions now. I just want you to have a quick look at them and see if you can help me with them later on. We can discuss the price.
It is also related about structural engineering.
Yes, it is structural engineering. Yes.
Yes. Okay. Okay. We can.
Let me just send it to you just real quick.
Okay. Okay. You can send to me. I am. Just a minute.
Right, just bear with me one sec. The connection's slow for some reason.
I am writing the answers along with that.
Okay.
Okay, question number 9 is class 1. 9. We don't need 8, 6, 5 equal to, I think, it's question 4, 75, question 3, 345, and question 1. Question 34.26 kilonewton. Okay, brother. And at the end, I just write on the Fiverr that I have completed your order. So it is my request to you to give me a very good feedback on Fiverr. Okay.
Okay. Do you have the answers for the ones we didn't cover as well?
And no, I don't have answers for them because it need to be calculated.
Oh. Okay. That's no problem. Those will do. Yeah, they're fine. Okay. If you can just give me a moment, I just want you to look at this piece of paper. It's just give me like 2 minutes.
Okay, okay.
Um, Okay, I've sent them now.
Okay.
I just want you to have a quick look at them.
Let's
See if you can deal with them.
show three options for the arrangement of the steel trusses in which explain those sketches and scenarios. Choose one seven internal stresses. Design studio assessment. Initiated. The principal and pressure explore three options for the arrangement. Three options for the arrangement of the explain to sketches the sense of function in each of the trusses. Choose one suitable stress point plus stress again. Okay. Okay. So one for example talk for choosing your system for a suitable section share explain the calculation which you have for section then determine whether the strength of the is that whether the indicator is axial force of 80 kilonewton factor the ULS already the sense of axial depend assume that okay list and describe the variable okay I think this is a complete project.
Sorry, what?
I think it's like a project.
It's an open book exam that we have. So
Okay, it's like an exam. Okay, but most of the time I have seen that it's just like a it's like a it's like assignment or project like that. But for now for this, what you need you need just a solution or you need for me to complete this work and send it to you.
if you can do that, because I want to get like full mark in it. It's 50 marks. I want to get full marks. If you think you can do that, I want you to have a look at it. If you can, then just let me know so we can
Okay,
just.
okay. Yes, we can talk about this. Okay, I can do it. No worry about that.
Okay. And by the way, is this lecture being recorded?
Yes, I have recorded this lecture.
Would you send it to me? Is that
Yes, I
possible?
will send it. Yes.
Okay. Thank you, brother. Thank you. Just let me know if you can do the 50 mark one that I told you about. If just have some time to
Okay,
think about it.
okay, brother.
Let me know.
Okay, and yes, I have completed the mark order on Fiverr. So could have give a good feedback. Okay.
Yeah, I will. Don't worry, bro. Okay.
Okay, brother. Allah
Okay,
Hafiz.
thank you, brother. See you later. See you.